work as far as graphing on Desmos, all that good stuff. The inequalities, we've done some going back to Unit 1 where we talked about the signs and stuff like that, where you get open circles, closed circles, right? That's from Unit 1. All right, so we're going to talk about this a little bit today. I think I just want to talk about, and I can double check here in a second, but I think I just want to talk about inequalities. Let me double check this, make sure I don't have it wrong. So let me check real quick. Just give me this a second ago. All right, yeah, we want to actually get on the systems as well. Okay, so we're going to try to move through this pretty quick today. We're going to go from linear inequalities to the system. All right, so linear inequalities, similar to a linear equation. So similar to a linear equation. Okay, it's very similar there, but instead of a equal sign, we know that it's going to use but uses an inequality sign. Okay, so very similar to the equation. You know, the work's the same. Only difference is you're going to use the inequality sign instead of an equal sign. Okay, so as far as your solutions go, if we think about our solutions to the systems of equations, how many total solutions could we possibly have for a system equation? What's one possible solution? One solution, right? What's another possible solution? No solution. And then the third is? Infinite. Okay. All right, so when we talk about solutions for linear inequalities, we're going to be talking about all of the ordered pairs. So all of the ordered pairs that make the inequality true. Okay? Somebody remind me what an ordered pair is.
X and Y factors?
Well, it's just going to be your x, y, in your parentheses, right? That's a point on the graph. Okay, so your x and y.
Good morning, Tupelo High School. This is Cole Kamal with your daily announcement.
All right, I'm going to go through the
Today,
announcements.
we'll be serving
We'll
chicken
just go ahead and
quesadillas
keep going.
and spicy fries.
All right, so one way that you can check to see if you have
Please see
an
Officer
inequality is you can
8104
plug it
during
in.
lunch
If
cycle.
we know
Pick
this
up
is
your
x,
2020-2021
this is
vehicle
y.
ID.
Right?
Please write down your
So
side
when we
number
plug it
and
in, we've
you
got
need to
2
be picked up
times
as soon as
x, which
possible.
is 2.
Student IDs
And
are
2 times 2
$5.
minus 3
Interest in
times
exploring
y.
Europe?
Okay,
Join us
y
as
is
we travel
5.
to Germany, Poland,
We want to
Hungary,
check to
the
see if
Czech
this is
Republic,
less
and
than
Cyprus by
15.
2022.
Right?
The interest
I
rate is
just
Thursday,
took the
October 1st
inequality
at
given
7
to me,
p.m.
and we're going to
Student
check to
Tucker,
see if it makes
105
it
for more
true.
information.
Okay? 2 times 2 is what?
NHS applications
4,
are open.
right?
There is a
Negative
link
3
with the
times
form
5
on
is?
campus. They are due Tuesday, September 29th by 2:30
Negative
for
15.
juniors and seniors only with a 3.5 GPA
Okay,
and
we
higher.
want to still check to see if this is less than 15.
THS and TMS track and field trials are September
What is
28th
4
through
minus
30th
15?
at 3 o'clock at the high school track.
Everybody,
All
don't do it in your
participants
head.
to bring a trial
Use your
waiver.
calculator.
Please bring a
4
mouse
minus
that will be
15,
required
plug it
for
in,
a master
Lavelle.
instructing only.
Negative 11.
Girls Aviation Day, September 26th, and Tupelo Aviation and Aero Services
Is negative 11
during static displays,
less than
information
15?
booths, and question and answer
Yes or no?
sessions with pilots,
Yes.
mechanics, and
All right,
flight
so
instructors.
this makes this
This event will
true.
take place at Tupelo Aviation, which is located at the
True.
airport from 9 until noon.
So that's
For
one
questions and
possible solution.
information, see your career coaches, Ms. Golden and
Okay.
Ms. Lunsford in A building.
Any questions on that?
Students, homecoming nominations are open. Please see your teachers for the links to
All right,
nominate.
so let's,
Voting will end today.
I don't know how many of these you want to do.
Tonight, volleyball plays
Mike,
versus
go through all
Alcorn
of them.
Central
All right,
from
let's plug
4:30
this
to
in. We've
6:30.
got 2
And swim has a meet at the
times
Tupelo
negative
Aquatic
1
Center at 4 o'clock.
minus 3 times negative
THS will
7.
pre-sell tickets
Is
this
this
week
less
at the home
than
ticket
15?
booth from 4:30 to 6 p.m. for the football game. The only
What
tickets
can I do
being
if
sold
this
on
is
Friday
left
night are
side?
the tickets left over from the pre-sale. Good
Can
luck
I
and
go ahead
go
and do
away.
it? Can I plug that all in the
Now please
calculator
stand
from
for
the
the
start?
pledge.
Yes.
Stand.
Okay, let's do this real quick.
Salute. Pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. And remember to be respectful, be responsible, and be safe. Have a golden wave day.
Alright, so here on this left side, we can go ahead and plug all that in the calculator. So on your calculator, you're just typing in 2, open parentheses, -1, Braylon, close parentheses, -3, open parentheses, type it in, -7, close parentheses, and then you're gonna press enter. It's gonna evaluate that for you and tell you what that left side is equal to.
19.
Okay, and that left side is equal to 19. Okay, so we drop that down, we say that's 19. We're checking to see if it's less than 15. Is 19 less than 15? No. Oh, it's not true, right? Not true. So is this a possible solution? Yes or no? No. Was this a possible solution? The first one, yes. Okay. All right, so let's check out 3, -4. So you got 2 times 3, okay, -3 times -4, okay, less than 15. Okay, this is the left side here, that 2 times 3 minus 3 times 4 can be plugged in. Just on your calculator, right, you would type in 2 open parentheses, 3 close parentheses, -3 open parentheses, -4 close parentheses. Press enter.
18.
Now left side equals 18. Is 18 less than 15?
No.
Oh, right, so is this a possible solution? No. Okay. So last one here, let's check out when we multiply by 0. So we got 2 times 0 minus 3 times 0. Okay, well we don't even really have to plug that in the calculator, do we? Why? It's all just gonna be 0, right? It's just gonna be 0 is less than 15. Is that true? Yes. So we can see here, based off the 2, 5 order pair and the 0, 0 order pair, that we have 2 of them that made the problem true, right? So that means that you're gonna have at least multiple solutions, right? You're gonna have a couple that can make this work, okay? So we want to see what that looks like on a graph and how we can represent that today is going to be our focus. Okay, but to do that, we want to be able to make sure that we know how to graph, okay, and what that looks like on the graph. Okay, a lot of times when you're graphing, if you were to do this by hand, okay, if you were to do this by hand, you would want this in slope what form? Intercept. Okay, slope intercept form. Okay, you've seen that with your equations, right? Same thing for inequality, right? Remember up top, we said that linear inequalities are the same thing as linear equations except with a inequality sign. So it makes sense that when you talk about slope intercept form that you could use it for both, right? One thing to watch out for if you're doing this by hand, Adrian, remember the rule about inequalities. If you ever multiply or divide by a negative, you have to flip that inequality sign. Y'all remember that? Yes? We talked about that in Unit 1. Okay. All right. So when we're talking about graphing the line, okay, when we're talking about graphing the line, you would want to use a solid line. Okay, if you use this symbol, greater than or equal to, or this symbol, less than or equal to. Okay, you would want to use a dotted line for when you use greater than or less than. Okay, what do you notice is underneath the inequality sign for the solid? It's kind of like it's already got a line there, right? And that's kind of reminding you, look, I've got this line underneath me, right? So you need to graph a solid line. This one doesn't have a line underneath, so you're going to use the dotted line. Does that kind of make some sense in a weird way, right? I'm trying to keep that up. Okay, you would shade above. Okay, we're going to have to learn how to shade. That you would shade above if you're greater than or equal to, right? Think about riding a roller coaster. If you've got to be, 70 inches tall, how tall can you be to ride the roller coaster? Okay, if you've got to be at least 70 inches to ride the roller coaster, what's one possible height that you could be? This isn't a trick question. Huh?
5 foot.
Well, I'm just asking inches. If you can be 70 inches, what's another possible solution? Can you be 71 inches? Yes, right? Can you be 72 inches? Right, you can start on anything greater than 70 inches, which would be above, right? So if you're using any of these greater than or equal to symbols, you would grab or shade above. Okay, below for less than or equal to. Any questions there? All right. Let's see. Briefly, I want to show how to work one by hand. Okay, this is not going to be our focus because everybody's got a new best friend that we're going to use, right? But if you were to have to do this by hand, okay, you want to get it in slope-intercept form. Remember, your slope-intercept form is y equals mx plus b, right? That looks familiar? Yes? Okay, where m is your slope and b is your y-intercept. Okay, so if I got to get this in slope-intercept form, and I've got to subtract my 2x to the other side. Okay, I've got negative 3y is less than negative 2x plus 15. Okay, my last step would be to divide by negative 3. And I would have y is, uh-oh, I about messed up, right? I divided by a negative, so what do I have to do with my inequality sign? Flip, right? So it's going to go from less than to greater than, right? So y is greater than 2/3 x, okay, minus 5. All right? So what I'm worried about now is being able to graph this, okay? The easiest way to graph it by hand, if you're doing it by hand, is first graphing your y-intercept. What is my y-intercept? Negative 5, right? So I'm going to go down here, 1, 2, 3, 4, 5, and I'm going to plot my point at negative 5. Okay, and then what's my slope? 2/3. What does that mean? What do I have to do? All right, you're going up. Remember, it's rise over run. Okay, so that means rise, you're either going to go up or down, run being left or right. Okay, so if I've got a positive 2 for the rise, that means I'm going up 2. If I've got a positive 3 for the run, then that means I'm going right 3. So now I've plotted my second point. How many points do you need to grab? 2, right? So I'm going to just connect these dots. Okay, I want to connect those and run it all the way through. Okay, it would look like this. Last part for an inequality. Last part for an inequality. I've got a shade. Okay, and actually I messed this up, so let me fix this real quick. What type of line should I have? A dotted, right? I don't have the equality, I don't have the line underneath. So really what this should have is a dotted line. Okay, a dotted line. So fix that. Y'all can just erase a little piece of the line. Okay, if you're writing notes, some people are just staring. Okay, and then last piece here is my shading. Okay, so if my inequality sign is greater, then which direction do I shade? Say up, above, right? So anything above this line will get shaded. So the question is, what does this shading mean for the problem? Okay, what the shaded means is that anything inside of that shaded region would be a solution to your inequality. Okay, so this point, let me change the color here. Okay, this point right here, is this a solution? Yes, right, it's in my shaded region, right? Okay, I've got a point here. Is that a solution? Yes, right? What if I put a point right here? Is that a solution? No, right? That's not in my shaded. Okay, one key piece. If you have a dotted line, like we have here, if a point falls on that line, so if a point is right here on a dotted line, that is not a solution. Okay, but if it's a solid line, it would be a solution. Okay, so that's the difference between your dotted and solid line. Okay, is everybody with me there? Yes, no? Okay. All right, so let's move on. Okay, we'll work a couple of these. I don't want to spend a bunch of time on this because we really want to focus on the systems part of it, where we have 2 linear inequalities. Okay, so what I want to do is y'all go ahead and go to that second page, and And we're gonna run through this left side here. We're gonna run through the left side on Desmos. Okay, so you keep the notes out. If you wanna follow along with me on your phone with Desmos, so you get the practice, or your computer, then I encourage you to do that. Okay, one option is not having your head on the desk, okay? Pick it up.
You want this recorded too, right?
All right, so when I look at Desmos, right, you're gonna pull it up, okay? Remember, just like the systems of equations, you can just type that in the way you see it, okay? So if you see number one, okay, number one here says y is greater than, so y is greater than, okay, 1/3 x, so 1 divided by 3, okay, 1 divided by 3, and then, oh, I'll put 33, my bad, let me fix that. Let's see, 1 divided by 3, x, okay, and then minus 5, okay, so let's take a look at my graph, okay, we've got a dotted line, which makes sense, right, because we didn't have the line underneath the inequality sign, so we got a dotted line, okay, this was greater than, so this gets shaded above. So on your paper, this is what you should be graphing, okay? Notice here that my y-intercept is at the point 0, -5. Okay, so you need to put a point on your graph, on your paper, everybody, at 0, -5, okay? Then you want to go by your slope. Okay, what is your slope? What's my slope up here? 1/3. So you're going to go up one space to the right 3. Okay, go up one space to the right 3. And I want you to graph this on your paper. Okay, so I should see everybody graphing this on the paper. Okay, and make it look like this. Shade above, you need a dotted line. Okay, you got a point at 0, -5. Okay, if you wanted to scroll over here, and I don't think y'all's graph would go all the way over here, but here could be another point that you plot where it crosses the x-axis, that's at 15, 0. I just don't think that y'all's goes all the way to 15 to the right. All right, y'all's is a little bit shorter than that, so that's where that slope is gonna be a little bit more for it. All right, any questions on number one here? Anybody need more time graphing this? I see a lot of people doing the shading, which means that we should be towards the end of that. Okay, make sure you graph. All right, number 2, or number 3, let's go number 3, I'm sorry. So number 3, is number 3, everybody look at number 3 with me. Is number 3 in slope-intercept form? No. Does it matter? No, right? When we plug it in Desmos, it does not matter. If you were to do that by hand, would it matter? Yes, okay? So for what we're doing here, it does not matter. So let's go 5x. I think, what is it, 5x minus 2y, plus 2y, 5x minus 2y, so minus 2y is equal to what? 12? Alright, it's not equal to, I'm sorry, we're doing inequalities, right? So what's my inequality sign? What's my inequality sign there? Greater than, okay? So greater than 12, okay? So, notice here, okay, which way is this shaded? Is it shaded above or below? It's below, right? What is my inequality sign here? What would that usually have told you to do? Above, all right, but notice, if you were to put this in slope-intercept form by hand, you would have eventually divided by a -2, okay, and that -2 would have done what to your inequality sign? Flipped it, right? So that's why you're shaded below. Okay, so here we've got a y-intercept where it crosses my y-axis at 0, -6. That would be a point I would plot at 0, -6. That's your y-intercept. Okay, then you've got another point that you can plot at 2.40. Okay, so that's going to be in between 2 and 3. That would be a point to plot. Or you could go by your slope. But it's hard to tell your slope from this, right, because it's not in slope-intercept form. Okay, so that's why you would want to pay attention to your intercepts, okay? The slope here, if you were to do it, is 5/2. Okay, so if you wanted to, you we go from 0, -6, up 5 over 2. Okay, you can do that as well. Or you can go based off your intercept. So graph this on your paper with a pencil in your right hand, put points on the graph. Okay, notice here this is another dotted line. Okay, so make sure that what you plot has a dotted line as well. Got it, Dave? Got it, Bree? Got it, Casey? All right, any questions on number 1 and number 3? What do you think? This okay so far? All right, let's look at, I think I'm gonna skip 5, but we can look at 7 and 8. Okay, so let's look at 7 and 8. Okay, so let's look at 7 first. 7 is y is less than 4. Okay, this is less than or equal to 4. So less than or equal to, y is less than or equal to -4. So -4. All right, look at my graph here. What do I have? It has a solid line, okay, but notice my line. What is it? It's shaded below, okay? But this is a perfectly horizontal line, right? Okay, and it crosses at what number for your y value? -4. Does that make sense? Yeah, right? So you've just got a solid line. It has no slope. Okay, so you're going to have this is number 7. Okay, this is number 7. You're going to have a point at 0, -4, and a straight horizontal line with a solid line shaded below. Okay, this is number 7. Okay. How would we have been able to tell that this has no slope just by looking at it? It doesn't have an x, right? That's what you would have wanted to notice. There's no x, so there can't be any slope. So all you have is your y-intercept, and the function that follows along that is just along that line when y is at -4. So along that line, thinking about that, okay, if we know that our whole function here is going to be at -4, y is at -4, what about number 8? Look at number 8. It says x is greater than 7. What do you think would happen for that graph if here at y, we went through the y-axis at that number? What would happen with the x one? We go through the x-axis. Would it be horizontal or would it be vertical? Your line. Vertical, right? We've seen this in unit 2 maybe, right? So at 7, you're going to have a vertical line. We'll graph that right here. So what is it? It's x is greater than 7. So x is greater than 7. Okay, well, you were right. We've got a vertical line where x is at 7, right? And it's any number we've got greater than, so it's any number greater than 7. Okay, so it's shaded to the right. Because to the right would be 8, 9, 10, 11, so on and so forth. Right? Is this making sense? Feeling good? Okay. Make sure that you're doing your graphs, not just sitting there with some dead eyes. Okay? Alright, so these notes that we just did here is on just one inequality. Okay, our focus today is what happens when we throw in a second inequality. Okay, so let's move to the next page. Okay, let's move to the next page. So I'm going to go back to the notes for a moment. Okay, let's get back to that. Let's skip past what we've done. Okay, and we've got systems of linear inequalities. Okay, so what a system of 2 linear inequalities is just going to be 2 or more. 2 or more system, or 2 or more linear inequalities. Okay, these linear inequalities is what we just did, what we just learned about. Okay, and so 2 or more linear inequalities that are graphed together. And then our focus today really is what is the solution to a system, okay? That is gonna be your overlapping shaded areas. Okay, and the way you'll hear me say it a ton today is your double shaded area. Which area of the graph has been shaded by both inequalities? Which area is shaded twice? Okay, that's what our focus is. Okay, anybody need more time writing this part? I know I'm moving semi-quick, okay, so just slow me down. All right, let's go ahead and move on then. All right, so I'm gonna do one of these by hand, and then we can look at the rest of these by Desmos. Okay, so our directions is to graph and then show all of the possible solutions. So for number one, okay, both of these are in slope-intercept form. Okay, so if I look at my top equation, I've got a y-intercept of -1. Okay, so I'm gonna put my point at -1. Okay, then I've got a slope that's also -1. Okay, so that's telling me if I've got -1, I can put that over 1, right? Any number you can put over 1 and it's gonna stay the same. So my slope would be down 1 to the right 1. Okay? So from that point, what type of line would be graphed? A dotted, right? So I'm gonna go through these 2 points with a dotted line. Okay? Put you some arrows on the end because it does continue forever. Okay, so I just graphed my first line. I did that one in red. Okay, I'll do the second one in blue. Okay, what is my y-intercept for the blue function? What is my y-intercept here? For the second one? -5. So I'm going down 1, 2, 3, 4, 5, and I'm plotting my point. Okay, my slope for that one is 1, right? So I'm going to go up 1, over 1, and I've got my second point. What type of line do I get? Dotted or solid? Dotted, right? We don't have the line underneath, so this is getting a dotted line. Okay, now what have I not done to this point? What's kind of important for the inequalities? What's kind of important for inequalities that we do? We've focused on the solid and dotted, and then we've also talked about the shading, right? I haven't shaded yet, okay? So if I look at the blue one, okay, if I look at the one I've circled in blue, the one I've graphed in blue, which direction does this get shaded? Above or below? What's my sign? Okay, my sign is less than, so that's gonna get shaded below. So for my blue, right, I'm shading anything that is below this line. Okay, I'm shading anything, and I'm not gonna do it perfect, but I would shade anything below. If I was doing it on your paper, okay, I would do one like this. Okay, I would shade one with lines like that, and I would shade the other like in the opposite direction, so that way you could tell which shade is the same shade. And what you would end up with, right, is this double shaded that kind of creates little boxes. It would tell you where your double shaded is. Okay, well, one thing that you could also do in that double shaded is put a big S, and put a big S in the middle so you know that's your solution. Okay, but let's look at the red. Okay, so for my red one, okay, what's my sign? Greater than. So which way do I shade? Above. Okay, so for my red line, I'm going above my equation. Now look what's happening down here in this bottom right corner. What's happening? I'm overlapping, right? I've got this double shaded area, right? And I'm gonna put that in purple. So let's look at right here, this little triangle area has been graphed twice, right? That is where my solutions can be. Okay, where this is shaded twice, that's where the solutions can be. So I'm just going to put a big S right there. Any order pair in that area could be a solution. Okay, so This point right here is a solution. This point right here is a solution. This point right here is a solution. Solution, 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 right? Anything in that purple area is a solution, Casey. Okay, is this a solution? Is something right here, is that a solution? No, right? It's not shaded twice there. What about up here in this red area? No, it's just gotta be in this double shaded area is where your solution is. Okay, so what you would see on problems today is, let's see, 1, 2, 3, 4, 5, 6, 7. Okay, is the point right here that I'm putting big, okay, is the point 7, -2 a solution to the system? What is your answer? Yes. Okay, is the point -3, -1 a solution to your system? No. Is the point 5, 0 a solution? No. Right, that's the type of questions that will be asked. Okay, any questions on that one?
Nope.
All right, let's see. Let's do a couple of these on Desmos. We're not gonna have a ton of time today, to get started on Khan Academy, so you're gonna have to do, probably all these at home today. Everybody can handle that, yes?
Yeah.
Yep, we've got it on our phone, we got it on the computer, and we wanna have good grades, right?
Yeah.
All right, so we need to make sure we're doing this, at home, right? Some of these classwork grades that I keep putting in are pretty rough. I don't wanna have to keep putting in a bunch of bad grades, especially when y'all are in class. Ain't that right, Coach Jackson?
No doubt.
All right, so let's look at number 3. Okay, let's look at number 3. All right, so number 3, we've got x minus 4y. So x minus 4y. Okay, that is less than or equal to 24. Okay, then we've got a second one. So you're gonna press the plus. You've got the second one, Casey. That is that y is less than or equal to, Casey, pick it up. 2x plus 1. All right, so look here at our, graph, okay? What do you notice in this area?
That's darker than the other one.
Well, it's darker because what happened?
It's double shaded.
It's double shaded. So which one of these areas is my solution?
It's double shaded.
This middle, right? Anything in this area would be your solution. Okay, so for graphing this, okay, notice both have solid lines. Okay, for the red, okay, you've got a y-intercept at 0, 1. Okay, and then you can plot that point, and let's see, there's your 3 points I would plot. Okay, there's your 3 points I would plot. Okay, and so you've got, what you would need to do on your paper is plot the point 0, 1. So plot the point 0, 1. And then plot the point 4, -7. Okay. Then plot the point 0, -6. Okay. Now look at your lines on Desmos. Okay, look at your lines on Desmos. You've got a line from that -4, 7 to the 0, 6. It's a solid line. Okay, graph that line. Okay, that one gets shaded above, right? From -4, 7 to 0, 6, that's your black line. Okay, and it gets shaded above. Okay, then you've got the line from -4, -7 to 0, 1. Okay, that line gets shaded below. Okay, and what's in the middle of those where it's double shaded is your solution. Okay, everybody's understanding, need help? Good? All right, so before we stop, okay, I'm looking for a couple of examples of a solution, okay? So somebody who feels comfortable, tell me an example of a solution to this system. We'll check it out. 5, 3. Okay, here's 5, here's 3. So this point right here, is that a solution? Everybody agree, yes or no? Yes. Okay, great job with Jalen. Let's get another one. What's another example of a solution? negative 2, 5 is up here. Okay, so that's
Oh,
not in the.
positive 2, 5.
Okay, positive 2, 5 is a solution, right? It falls on a solid line, which would mean it's a solution.
Right, on the line. We can-
Okay, now if that was dotted, that wouldn't be a solution, but since it's solid, that is. Okay, what's another example of a solution?
6, 5.
Okay, 6, 5. Is this a solution? Everybody agrees? Yes? Okay. Somebody else, somebody different. We've heard from 3 people. Let's hear from somebody else. What's the solution here?
Now, don't be shy. Come on now. It's easy. It's the easiest thing you ask. Pretty tough.
What we got? Let me get one more and then we'll call it a day.
Negative 2, 6.
What'd you say?
Negative 2, 6.
Negative 2, 6. Negative 2, 6 is up here. Okay, so that's not gonna be a solution. Let's try again. 10, 5. 10, 5 is right here. Everybody agrees that's the solution? Yes? Okay. So today, you've got 3 Khan Academies and only about